Hello, my name is Nikhil Sagar and I am working as an assistant professor in the department of BCA, IIMT College of Management. Today we are going to discuss the topic parameter passing. Now we are going to cover these following topics, that is, what is a parameter, what are its types, formal parameter, actual parameter, parameter passing and its types like call by value and call by reference. So now let's look at the first topic, that is what is a parameter. A parameter refers to a variable or a value that is passed into a function when the function is called. Parameters are used to provide input to a function, allowing the function to perform its specific task with the provided values. So now let's look at this definition in more detail. Okay, suppose we have to make a function to add two numbers. Okay, now to add two numbers, for example, if we don't have to make function, we have to make a simple program. We want to add two numbers. Okay, we want to make a program in which we are going to add two numbers. So what inputs we are going to need? We are going to need two variables that will contain two values, and then after taking the values into the variable, after storing the values into the variables, we are going to add both the values and print the result. This is what we are going to do in the normal case. Okay, so like this only we will doing the same thing when we are making a function. Okay, so if we may make a function to perform the operation of sum, then what we are going to do, we are going to make a function named add. So that add function will require two values. Okay, two values, two numbers, which the function is going to add and return the answer. It is going to need two values. Okay, so either we can declare those variables inside the function, or we can take the input values into those variables, or we can take those values from the outside function, that is the main function. So this is where the parameter passing comes into the picture. So at the time of function calling, as I have written here, at the time of function calling, a variable or value that is passed into a function, that is known as a parameter. So at the time of function calling, the variable or value that is passed into a function is known as parameter. For example, we have taken the example of addition here. Okay, for example, we have made a function named add. So how to call the function add? We will simply write add, and in the bracket what we are going to write, it will be known as parameters. Okay, it will be going to known as parameters. So this is the syntax of function calling. We will write here the function name and then the parameters. What are the parameters? We have already discussed that parameters are values or variables that are passed into a function. Okay, so we will call this function and write here a comma b. Why we are writing here a comma b? Because we have already declared these variables int a comma int b, and we have taken the values of these variables. Okay, we have stored the values in these variables. For example, a equals to 10, this number is given by user, and b equals to 20, this number is given by user. Now these numbers are stored in a and b, 10 and 20. This means that we are passing 10 and 20 to the function. Okay, so like this same, here is the function definition, int add, and in the brackets I have already told you, here we will write int a comma int b, int a comma int b. So I have already told you that we are going to need variable to store the values. Okay, so from here we are passing a and b, meaning we are passing the values of a and b. So these two values will be stored where? If the function add has to use these values, then it has to store these values. So the values of a will be stored in int a and b will be stored here in b. So these values will be transferred here. That means it will contain now 10 and it will contain 20. These values are transferred to these variables. That's what we discussed in what is a parameter. A parameter is a value or variable that is passed into a function. So these will be called here as parameters, and we have also written that it allows the function to perform its specific task with the provided values. So these values are provided to the function. That means these values are transferred to the functions, and these variables or parameters, they act as placeholders to store these values. They are acting as placeholders. Okay, when these values will be passed to this function, then only this function can use it. Okay, so here we have already taken the value of a and b from the outside function, that is the main function. So we do not have to declare int a and int b here again. We will not declare int a comma int b. Okay, we will write here simply return a plus b. That means we are simply returning the answer a plus b. Okay, so I think now you have understood the point, what is a parameter. Now we are going to discuss what are the types of parameters. So let's discuss it in a bit of detail. So parameter has two types, that is formal parameters and actual parameters. Now let's look at the formal parameters and actual parameters one by one. Now formal parameters. So formal parameters are the variables declared in the function prototype or definition. This point I have already covered, that the variables present inside the function definition or the function declaration are known as the formal parameters, and they are used to store the values that are passed at the time of function calling. They act as placeholders for the values that will be passed when the function is called. So yes, they are acting as placeholders. They are storing the values provided at the time of function calling. After this third point, formal parameters are listed inside the parenthesis of the function declaration and definition. This point I have also covered, that these formal parameters are listed between these brackets. Okay, so all 3 points we have already discussed. Now let's look at the actual parameters. Actual parameters, also known as arguments, are the values or expressions passed to a function when it is called. This point we have also covered, that the values or the variables that we are passing at the time of function calling, those will be known as actual parameters. For example, we are calling the function add. And we are giving the variables here a comma b. So these variables will be known as actual parameters. Okay. After that, next point, they provide the actual data that the function will operate upon. So yes, these variables will provide the actual data that the function will operate upon. Okay, for example, there is an addition function. It will work on that data which is passed at the time of the function calling. Actual parameters are specified in the function call. So yes, we have already discussed this, that the actual parameters or the variables that are used at the time of function calling. Okay, now let's look at the next slide. Now we have came to the most important part of the video, that is parameter passing. Now we are covering the main topic, that is parameter passing, because we now have the knowledge about what is a parameter and what are its types. Okay, so parameter passing in C refers to the mechanism through which values are passed from one part of a program, usually the calling function, to another part, usually the called function. So what is parameter passing? Parameter passing is the transfer of the values from the calling function to the called function. The transfer, I am repeating it again, that parameter passing is the transfer of values from the calling function to the called function. When a function is called, it may require some input values to perform its task. These input values are known as parameters or arguments. I have already discussed about this with an example program. That is, if we have to make a program for addition, then it will require two inputs, number 1 and number 2, and then only it is going to add those two numbers and provide us the result. So those two numbers will be used at the time of function calling. Then it will be known as actual parameters, and then the value of those variables will be passed to the called function, and the variables which are going to store those values will be known as formal parameters. Okay, so this is what parameter passing is, the transfer of values from the calling function to the called function. Okay, now let's look at the types of parameter passing. So parameter passing has two types, call by value and call by reference. We are going to take a look at both of them one by one. First is call by value or pass by value. In pass by value, the actual values of the arguments are passed to the function. The called function works with the copies of the values, and any modifications made to the parameters inside the function do not affect the original values outside the functions. So here, at the time of function calling, we are going to pass the values of the variable, and after passing the values of the variable, the work is going to be done on the copies of the variables. Okay, the work is going to be done, that is the function is going to be performed on the copies of the variable, and if we made any changes to the variables, then it will not reflect on the original variables. We will see this concept with a simple example. Okay, for example, let's see. For example, we have made four variables, int a, b, c, d. We have declared four variables, so these four variables will have space in memory like a, b, c, and d. They will have space in memory like this, and the value will be stored here, and this will have some unique addresses. Okay, for example, we are storing 1 and 2 in a and b. Okay, now I write c equals to a and d equals to b. What does it mean? This is the assignment operator. It means that transfer the value of a to c. This means transfer the value of b into d. So what will be the new values of c and d? C equals to a, that means 1. D equals to b, that means 2. The value of c and d will be 1 and 2. 1 and 2. Okay, you have understood this part. C equals to 1 and d equals to 2. Now if we made any changes to the values of c and d, will it reflect on the original variables, that is a and b? The answer is no. If we write c equals to 3 and d equals to 4, will it change the values of the variable a and b? No, it does not change the values of the variable. Like this only, at the time of function calling, the values of the variable are passed to the function and the work is done on the copy. Okay, we will see this with the help of an example. So now this is the example. So let's see this example. Starting from the first line, hash include stdio.h, that means hash include preprocessor directive is used to include the header file stdio.h. Why we are including this header file? We are including this so that we may use its functions like printf and scanf, which are declared in this header file. After that, we are making a function to swap two numbers here. So we have written void swap numbers int a, int b. Void here is the return type. That means the function will not return any value. If the function is not returning any value, that means that we will have to print the result in that function itself. Okay. After that, the function name, that is swap numbers. In the brackets, we have taken two variables, int a, int b, and these variables are known as formal parameters. Okay, these variables act as placeholders, and these are going to store the values that will be passed into the function, semicolon. And why we have declared it? Because just like a variable, before using a function, before defining a function, we have to declare it. After that, we come to the main function. Here it is also written as int main, brackets are left blank. This means that the function will return integer type values like 0, 1, 2, -1, -2. These type of values the function will return. Main is the function name, and brackets are left as blanks. That the it means that the function is not accepting any values from outside. Then curly braces and then start. Here we have written int num1 comma num2. That means we have to created two variables, number1 and number2. We have created two variables like this, number1 and number2. That means some memory is allocated to these variables, okay, and these will have some address, and the value will be going to store in these variables, okay. So now we have taken the values of these variables. Printf enter the first number, okay. Output will be like this, enter the first number. Now user here has entered 10. So 10 we are going to here store the address of the number 1, because we have written here scanf %d comma address of number. That means store the value provided by the user at the location of number 1. So 10 is stored here. After that, printf enter the second number. So the output will be as follows, enter the second number. So user has entered 20. So we have written here scanf %d comma address of num2. That means store the provided value at the location of number 2, at the address of number 2. So we have stored 20 here, okay. 20 is stored here. Now we have printed the output before swapping. So printf before swapping, number1 equals to %d, number2 equal to %d comma sum, number1 comma number2. What are the values of number1 and number2? 10 and 20. So these values will be printed at these places, %d and %d. So 10 and 20 will be printed at these places. So the result will come like this. Before swapping, number1 is equal to 10 and number2 equal to 20. This will be the result. After that, we have made a function call. Function call with actual parameters, as we already know that the function that the variables that are used at the time of function calling are known as actual parameters. That's what we have written here. So what is the syntax to call a function? We just simply have to use the function name, and in the brackets we provide the actual parameters. That's what we have written here. Swap numbers in the bracket number1 comma number2. That means we are going to pass the values of these variables, that is 10 and 20, to the function. We are passing this, okay, and I have already explained you that when a function is called, then the function control is transferred to the function definition. So after this function is called, the control is transferred to the function definition. That means the control is transferred here. So we came here, and the values of these variables will be passed into the function. This we know. So this 10 is passed here and 20 is passed here. That means this contains now 10 and this contains 20, okay. And these variables are known as formal parameters because they act as placeholders and they store the values that is passed to the function. So now they are going to store 10 and 20. Now this contains 10 and 20. This means that we do not have to take input in this function. We have already took the input in this function and then we have passed those values in this function, okay. So in this function we are performing swapping. You must already be familiar with the concept of swapping, but let me explain you again, okay. Suppose we have two variables a and b. We have two values a and b. A is 10 and b is 20. We want to swap these values. That means 20 should come here and 10 should come here. A equal to 20 and b equal to 10. This is what we want. This is what we want, okay. This will be the result. We want this type of thing, okay. So no problem. You will say that we can do like this. We can transfer the value of b to a, 20. Now the new value of a is 20. That means the old value will be overwritten. That means 10 will not be here. Now a contains 20, okay. Now we want to swap b. That means we want to transfer the value of a to b. Now what we see, that the value of a is now 20. So how can we swap b? If we transfer the value of a to b, then also b will remain b will remain 20, and these two will remain the same. So the swapping is not done. That's why the concept of using the third variable came. So that's why we are using the third variable. Now let's have a look. So the value, so to preserve the value of a, so that it should not be overwritten. So to preserve this value so that we may transfer it to b afterwards, we are going to need a third variable. For example, a is 10, b is 20. If we transfer the value of b to a, then a will become 20, and then we cannot swap a with b. We cannot transfer 20 to b, then b will remain same. So what we are going to do, so to preserve this value 10, so that afterwards we can transfer it to b, we are storing this value in c. So 10 we are going to store in c. So 10 we have transferred here. Now a is empty. Then 20 we are going to transfer in a. Now a equal to 20. Okay, the swapping of a is done, equal to 20. And now we are swapping the value of b. So b needs 10. So here we transfer the value of c to b. So now b will become 10. Now the swapping is done. Earlier they were 10 and 20. Now they are 20 and 10. Okay, now let's look at how we will write the code for this. We will write as follows: c equals to a. That means first transfer the value of c, first transfer the value of a to c, so that the a value of a will be preserved. After that we write a equals to b. That means transfer the value of b to the variable a. This is what we want. After that we want to transfer the value of a into b, and the value of a is already stored in the variable c, so we will write here as b equal to c. This is how the swapping is done. Okay, for example, a and b had already values 10 and 20. So the value of a, that is 10, is transferred to c, so c has become 10. Then we have written a equals to b, that is the value of b will be transferred to a. B was 20, so now a is 20. Okay, then the value of c is going to be transferred into b. The value of c is 10, so now b equals to 10. This is how the swapping has worked. That's what we have written in our program. Int, here we have also made a third variable, int temp equal to a equals to b equal to temp. So this is how the swapping worked. So now we have swapped the numbers, but we have swapped the copied numbers. Okay, we have made a copy of these variables. For example, I have already explained this to you. These two variables, num1 and num2, these are different, and these two variables, they are different. Only the value of this variable is transferred into this variable, value of this variable is transferred to this variable. So if we made any changes to the value of this variable, it will not reflect on the original values of these variables. That's why we have printed, after performing this swapping, we have printed the result of swapping inside this function. So we have written printf inside swap function, swap values a equal to %d, b equal to %d, and here the output of swapped values will be printed. For example, a equal to 20 and b equals to 10. After this, the program control again goes here. Here we have written printf after swapping, values in the main function remain unchanged. Num1 equal to %d, num2 equal to %d, because now we are talking about these values, number 1 and number 2, so these will remain unchanged. So here the result will be num1 equal to 10, num2 equal to 20. Here we have also written the same thing after swapping and inside swap function. So now we have understood the concept of call by value. So here all the work is done on the copy of the variable. Original value is not affected by call by value method. Okay. Now let's move on to the next method, that is call by reference. Call by reference or pass by reference. In this, the memory addresses pointers of the actual variables are passed to the function. That means in this, the variables, the copy of the variable are not used. In this, the direct memory address is passed to the function and all the changes are made at the exact address of that variable. So the changes made are permanent and are also reflected in the original values. In path by reference, the memory addresses pointers of the actual variables are passed to the function. The called function can then access and modify the values stored at those addresses, leading to changes in the original values. That's what we have already discussed. That in the pass by reference method, we are passing what? Address. We are passing the direct memory address of the variables. That means all the change is going to be done on the actual address, and this will be the permanent change. So if we make the same function with the pass by reference method, then what will happen? If we print the result in the main function, that is swapped result in the main function and swapped result in the swap function, then both will return the same answer. Why? Because we are passing the memory address of the variables. So all the changes are done on the actual memory address and the values are changed for permanent. Now let's look at this pass by reference with the help of an example. So here we have taken the same example, but in this case we are not going to pass the variables. We are going to pass the memory addresses of the variable. So all the changes made will be permanent. It will reflect on the original variable. Starting from the first line, we have written hash include stdio.h. That means include the header file stdio.h. After that, void swap numbers int asterisk a comma int asterisk b. So here what we have done, it is the function declaration. As I have already told that before defining any function, we have to declare it. So the syntax remains the same. Void, that means the function will not return any value. Swap numbers is the name of the function. Now here comes the important part. Here it is written int asterisk a, int asterisk b. What I have told, these are the formal parameters because they act as placeholders and they are going to store the values provided at the time of the function calling. The values which will pass are stored here. So these are known as formal parameters. But we have discussed in call by reference method that memory addresses will be passed to the function. So memory addresses are stored by pointer variables. Memory addresses are not stored in normal variables. Memory addresses are stored in pointer variables. So we can store them, we can access them also by their addresses. So that's why we have written here as int asterisk a, int asterisk b. So these both are pointer variables. What does the pointer variable do? It stores the addresses of the variables. These are pointer variables. Why we have used this pointer variables? We have used this because we are going to store the memory addresses of the variable, not the values of the variable. I hope you got the point. Now we come to the main function. Here we have made two variables, int num1 comma num2. That means two variables will be created, num1 and num2, and they will be allocated a space in the memory, and these variables will have some memory addresses. Okay, value will be going to store here. Now we have written printf enter the first number, scanf %d comma address of num1. This means firstly this line will be printed on the screen, enter the first number, then user will enter the first number. And how this number is going to be stored? Here we have written scanf %d comma address of num1. That means store the provided value at the location of the number 1. So whatever value the user will provide, suppose the user has provided value 10, then the value 10 will be stored here. After that, printf enter the second number. So now this message will be printed on the screen, enter the second number. Now user will enter the second number, and how that value will get stored in the variable? We have written scanf %d comma address of num2. That means store the provided value at the location of num2. So now the next value, suppose the user has provided 20, then 20 will be stored here. 20 will be stored here. Okay, and we can also access these variables by accessing their memory address. After that, we are printing the result before swapping. We have printed printf before swapping number 1 equal to %d, number 2 equal to %d, comma number, comma num2. That is, before swapping, the result is number 1 equal to 10 and number 2 equal to 20. This is how we write the result. After that, we have made a function call. How do we call a function? We just simply write its name, that is swap numbers, and in the brackets we provide the parameters. At the time of function calling, the parameters that are used are known as actual parameters. These parameters are the values or the variables, okay, that are passed at the time of function calling, and they are known as actual parameters. So what we have discussed, that at the time in the call by reference method, the values or the variables are not passed. Actually, the addresses of these variables are passed. So that's why we have written here as address of num1 and num1 we have written. That means address of num1 comma address of num2. Now in the before, that is in the call by value method, 10 and 20 will be passed here. But in this method, for example, I'm just taking an example. So in this method, 2137 and 2157 will be passed here. This will be passed. Then we are printing the result after the swapping. Output before swapping, printf after swapping, number 1 equal to %d and number 2 equal to %d, num1, num2. This is the output after the swapping. So if we have swapped the numbers, then the output should be number 1 equals to 20, number 2 equal to 10. Why? Because any changes we made in the call by reference method, any changes we made to the variable will be permanent, because they are done at the original memory addresses. So here the answer will also be same. Here the values will be printed are the swapped values, that are 20 and 10. Now let's look at here. After we make a function call, the program control will not come here to the second line. The program control will go to the function definition. So here we have written void swap numbers int asterisk a comma int asterisk b. Void is the return type. That means the function is not going to return any value. That means we have to print the result here itself. We are not going to return any answer. Then swap numbers is the name of the function. In the brackets, I have already told you, I have already discussed that these variables work as placeholders, and they are going to store the values that are being passed to the function. For example, here when the function is called, then here addresses are passed 2137, 2157, and these variables are going to store these results. And I have already discussed that to store the memory addresses, normal variables are not used, pointer variables are used. That's why we have written int asterisk a comma int asterisk b. So this is the format. After that, curly braces, and then the swapping process is done. Swapping process, I have already explained. They have taken a temporary variable and then they have transferred the value of asterisk a. What is the meaning of writing asterisk a? Asterisk a meaning that we are going to access the value of this variable. Meaning of writing asterisk a is the value that is stored at the memory address of a. This is the meaning of asterisk a. Asterisk a means the value at a. The value at a. Value at a is 10. Then 10 is stored at temp. Okay. Then it is written asterisk a equal to asterisk b. That means asterisk b is 20. That means asterisk a contains now 20. After that, asterisk b equal to temp. Now temp contains 10. So asterisk b is equal to 10. Now they are swapped, a and b equal to 20 and 10. Now we are printing the result. Output within the function printf. Inside swap function, swapped values are %d and %d. So here the swapped answer will be printed, that is 20 and 10. So this is how the call by reference method works. Any changes made to the values will be also reflected on the original values, because the changes are made at the original address of the variable. Here is the output. Enter the first number, the user has entered 10. Enter the second number, the user has entered 20. We have printed the result before swapping. So before swapping, it is number 1 equal to 10, number 2 equal to 20. After that, we have called the function. So inside swap function, the result is a is 20, b is 10. These are the swap values. After swapping, in the main function, num1 equal to 20 and num2 equal to 10. So in both the function, main function and the swapping function, the answer is printed after the swapping of the values. So we see here that the original values are changed because they are changed at the original memory location. So I hope that you have understood the concept of parameter passing, call by reference and call by value, and the difference between both of them. So thanks for watching my lecture.